Welcome to the solution video for the calculations challenge. Let's dive right into the code. So we'll go to New Project, and we'll select a console app.NET Core. And let's call this the calculation challenge, and we'll call it calculation challenge app. I'll create that. And once we're done creating, we will get rid of the console write line. We don't need that. But we will add a console.read line at the end. Now, I haven't turned it off. Some people do. It's up to you if you do or not. But when you run this, notice I have the blinking cursor there for the console read line. But if I hit enter, it's technically closed already. The application's closed. Notice my green start arrow is back instead of the stop, but yet the console is still open. So it says that it's exited with code 0, and if you want to automatically close the console when debugging stops, then you can enable this right here. I'm not going to enable that right now. So just know that you don't technically need this if you have that the same way I do, where it still stays open even after the application is closed. So it's up to you in .NET Core if you want to continue using the console read line at the end, or if you do want the application to fully close out. I like to have the console read line because it's much more production ready. So with our console read line in place, we now need to create our new class. We won't create a class library for this. I think it's overkill at this point. Reading these values, which is why they're just a get. But what we got to do now is we got to fill these values every time the temperature changes on the insert. But that's actually pretty easy. So what I'm going to do is say minimum temperature equals temperatures, that's our list, dot And this is where we need to have a using statement. So if I were to say average, do control dot and add the using statement for system.link. Say average like so. And that will give you my average for my, whoops, haha, not average, min. We'll get to average in a minute. Maximum temperature equals temperatures dot max. And then average temperatures equals, and here's where we go, temperatures dot average. We already have the calculations done for us, basically. But I'm doing these calculations on the insert, not on the get. That way, we update these three values internally every time we insert. And so when we go to read, we're just saying get an integer or get a double. That's all we're doing. We're not actually doing any kind of calculation in our property. So with that, we have our temperature class. So now we need to actually fill it up and make sure it works. So let's create we're going to do an insert for 100 random values. So let's create a random number first, a random number generator equals new random. We're going to do a for int is less than 100 because we're going to insert 100 random temperatures. So 0 to 99. And we're going to do let's also create our temperatures. Temperature equals new temperature. So we can say temperature dot insert. We need to pass an integer. What is that integer? Well, it's rnd.next. And the values are 1 to 101. And there's one of the tricky bits. Because the random number, it's going to include 1, but be 1 lower than the maximum. So therefore, 1 to 100 is 1, 101. So that's our insert. And now we can do our console write line. We'll do our string interpolation to say min temp, and inside here we can say temperature dot minimum, like so. Then we'll copy this line a couple times. We'll say max and average. Just make sure you change Interestingly, min of 2 and max of 99, an average of 52.42. So we're getting a little closer to the average, but we didn't get a 1 or a 100 in our temperature range. Okay, so that concludes the main part of the challenge. So now we undertake the next part of the challenge. The first thing we need to do is we need to have a public void insert that takes in a string temperature. Let's call it temperature, is fine. So instead of a integer, it's going to take in a string. and we need to somehow convert that over to a number. Now, strings are tricky. So what we're going to do is I am going to create a private dictionary string int. And let's call this words. Like so. So there's our private dictionary. It's got a type string as the key and int as the value. Normally it's the other way around, but in this case, I'm going to pass in ONE and I want the numeric equivalent. But we need to populate this, and that's going to take some time to type out. So I've pre-done it for us. So let's create a constructor here and just pre-populate it. So I use better word. Let's just update that. There's actually an easier way of doing this. I should have done it, but that's okay. So now we've got words from 1 to 10 and their numeric equivalent added to our dictionary. Guess how easy this is? We can just say insert and then pass in our words with a square bracket, temperature. Okay, you see what I did there? I've got a dictionary. I passed in this, which is the key, and I got the value for it. Now, yes, I am assuming that you're going to give me an ONE all lowercase. That may be something we need to work on. Well, not a problem. We can say temperature equals temperature to lower. Now, the more string manipulations you do, the less performant your application is going to be. I am not assuming we're going to insert 30,000 records right away. I'm not assuming we're going to do tons of these inserts. If we were, we'd have to even ask the question, can we do this? Or do we need to bring in some kind of asynchronous task to do it or something like that? Because of the fact that strings are not performant. That's what it comes down to. But for our case, as long as we're not doing more than, 10,000 every 10 seconds, that's really what it comes down to, is we probably do 10,000, 20,000 in a 10-second span. So as long as we're not doing that many inserts, we're okay. In our case, nowhere near that much. So we have our insert with the temperature. Now let's go over and actually call it. So we got these inserts here. words instead of numbers, or both, either way. And again, I can add to 1,000, I can do 10,000, and let's just drag this over real quick, but it just pops on the screen really quickly. We've only been running for 5 seconds now and I haven't been talking. So we can do a lot of numbers here. If you put 50,000 in there, you're going to wait. But anything 10,000 or below, you're good. In our case, we only needed 100, so we have no problems there. All right, next part of our bonus challenge is to create an interface for this temperature class. That's not that hard. Control dot when you've got your cursor on the class name. And the last one is extract interface. iTemperature, new file, and if you expand this out, we've got the 3 properties and 2 methods. Hit OK. And now if you look at iTemperature, we have our properties with just the gets. We have that private set. Remember, an interface is only for the public options. So we don't have the sets in here because they're private. So that's our interface. Now we can come back over here to our class and just say iTemperature instead of temperature. It changes nothing. I mean, it all still works. In fact, we could do both of these like so. So now we're inserting 200 values, and some of those values are from 1 to 100, some are from 1 to 10, therefore it's going to drop our average pretty significantly. But if we run this, note that our average is much lower, our min and max are about the same, and our performance is still the same, and it didn't crash anything to use iTemperature instead of temperature. Okay, so that's the next step, but then here's the tricky one. Without breaking the interface, so now we can no longer touch this interface. Without breaking it, optimize for insert instead of read. So the problem with our insert is we're doing these calculations in the insert, and that slows down the insert. Well, what we can do is we're going to modify this get. And you say, but we already have an interface set up. Yes, and this is one of the beauties of properties is an auto property is a property. So I can break these out and say, you know what? I actually want to have a get method. Now, the set is going to be a problem. But no worries. We have a private int underscore minimum temperature, like so. And I'm not going to have a set because I can now modify this instead. So I can say return, and in fact, I don't need to have a private int. I can say return temperature.min, like so. And I can do the same for the other two. Let's just comment these out so you can have the alternate version. In fact, I should do the same thing for these. Let's do that. Let's copy this and paste it. And I'm going to name it minimum temperature. I'm going to comment it out. Same thing with maximum temperature and average temperature. So you can't have both of these, the properties, the full property and the auto properties. But that way you can have either one when you're doing your testing. Just comment out one, uncomment the other. So I'm going to copy this. I'm going to paste it twice more. We'll have our maximum temperature. Make sure we change this to be our max. And then we'll have our average temperature, which is going to be average. And that's not type int, it's type double. how you optimize things, and how you do properties so you can use interfaces without breaking the interface. A lot of things you can learn here. So pick out the things that really work for you, things that you might not have noticed, and maybe study them a little more and practice them a little more. Remember, practice makes perfect, or at least practice makes better. And the more you practice, the more comfortable you will be using these different techniques. Okay? Thanks for watching. As always, I am Tim Corey.